Hi friends, just now we have discussed about the moment of inertia about a iron rod, about its center perpendicular to the length of the rod. Now same thing what we will do is, we will find out the moment of inertia of the thin rod about an axis about one end. Okay, moment of inertia about one end. మీకు అర్థమవుతుందా? ఇందాక మనం అబౌట్ అన్ యాక్సిస్ పాసింగ్ టు సెంటర్ ఫైండ్ చేసాం. నౌ విల్ ఫైండ్ ద మొమెంట్ ఆఫ్ ఇనర్షియా అబౌట్ వన్ ఎండ్, either this end or this other end. Now here also again the body is not a point mass. The mass is uniformly distributed. You can చూడండి మొత్తం ఒక ఐరన్ రాడ్, థిన్ ఐరన్ రాడ్, మాస్ మొత్తం డిస్ట్రిబ్యూట్ అయింది. సో యూ హ్యావ్ టు టేక్ అగైన్ ద ఎలిమెంటల్ లెంత్ dx. So out of this one I am considering a small elemental length dx. Let the mass be dm and let that elemental length plate small చిన్న ముక్క, it is at a distance x from the reference axis y dash. Same fashion again, linear density mass per unit length dm by dx. Again rho dx is equal to mass, that is dm of the elemental length. To get the entire moment of inertia of the entire rod, you have to again integrate, but here the limits is not minus L by 2 to L by 2 plus L by 2 because it is from one end. So 0 to L the limits. So integration of dA is I, and rho dx x square, again what happens, x square dx integration enta x power n plus 1 by n plus 1, that is x cube by 3, and the limits again 0 to L because this end to this end. So we will apply the limits, upper limit minus lower limit of the function x. So L cube by 3 minus 0 cube by 3 అంటే ఇది క్యాన్సిల్ అయిపోతుంది. సో ఏం మిగిలింది మనకి, rho L cube by 3. But what is the linear density of the entire rod? Mass per unit length. So capital M is the mass of the entire rod, length L is the length of the rod. Therefore rho into L is the capital M. Now substitute this value in this here. Here you can see here, because already we got rho L cube by 3. So rho L into L square, but rho L is what? Capital M, mass of the entire rod. Therefore the moment of inertia of the thin rod about one end is given by ml square by 3. Very very important formula in doing numericals of MSET and NEET problems. Okay, right.